Hey guys, this is Miss Morrell here, and I'm doing Mr. Cook a solid this week and doing the warm up question explanation so that he doesn't have to. And I'm here to go over the warm up questions from December 7th and 8th. So, some of these questions we are revisiting that pesky concept of potential and kinetic energy. So, if you'll remember, potential energy is stored energy. It's the potential for movement. So it's stored. There's no movement yet. And then kinetic energy is the energy in movement. If there's movement, there's kinetic energy. Potential plus kinetic energy equals mechanical energy. So think of potential and kinetic energy as together in a system. So if you've got your skier at the top of the hill, he's 100%, he's standing still, he's got 100% potential energy and zero kinetic energy. As he goes down the hill, potential energy decreases and kinetic energy increases, and it's 100% kinetic energy. But somewhere in the middle of that hill, maybe he's still a little up on the hill, it's maybe 60-40, but it still equals 100% of the mechanical energy. So as potential energy decreases, kinetic energy increases. So here's our question. A high diver steps off a diving platform that is 10 meters above the water. If no air resistance, so that means friction, if no air resistance is present during the fall, will there be a decrease in the diver's A, potential energy, B, kinetic energy, C, momentum, or D, speed? Well, if he started off at 10 meters and he steps off the platform, his elevation is dropping, his height is dropping. So his potential energy would be decreasing, and therefore his kinetic energy would be increasing. So the answer is there will be a decrease in the diver's A, potential energy. Question number 2, also about potential and kinetic energy. Which of the following best describes the wagon's change in energy as it coasts from point X to point Y? So here's the wagon, here's point X, and here's point Y. So just looking at this, you can see this wagon just finished going up the hill. So right here, it has more potential energy than it did here, or than it will here. But this is not a very big hill. And it's going to gain kinetic and lose potential as it goes down. And then it's going to go back up where it's going to gain potential, but it's going to slow down a lot because this hill is bigger than this hill. So let's break it down. What is the change in energy? Will it have the same kinetic energy at both points? Well, no, because technically at those points, it doesn't have any kinetic energy. It's all potential energy because for that split second, it's still at the top of the hill. B, the wagon will have more kinetic energy at point Y than at point X. No, not only is it at that point where it's at the top of the hill and it's still, this is a bigger hill than this one. So by the time it gets to the top of the hill, right before it's at that exact equilibrium point, it's going to be going slower, actually. It's going to have less kinetic energy. C, the wagon has the same potential energy at both points. Nope, this one is a lower point, so it has less potential energy. Or finally, the wagon has more potential energy at point Y than at point X. Yes, this is true because point Y is a higher point than point X. So there's more gravitational pull, so more potential energy. So number 2 is D, the wagon has more potential energy at point Y than at point X. Number 3, question about the cart again. A cart at the top of the hill is released and rolls down the hill. Which of the following describes the energy of the cart just as it reaches the bottom of the hill? Well, you know it has energy because there's 100% mechanical energy in this little system. But does it have maximum kinetic energy? So we can go back up here and just look at this little picture. So as this wagon rolls down the hill and gets to the bottom, that's the fastest it's going to be going. It has no potential energy and 100% kinetic energy. So yes, that would be the maximum. And it does not have equal gravitational and potential energy, because that would be someplace here in the middle, here or here. So the answer is B, the cart has maximum kinetic energy at the bottom of the hill where it's going down. It's finished going down, but it hasn't started going up yet. Number 3, we kind of switch gears and go back to 7th grade for photosynthesis. So we've given you a picture, a lamp, a test tube. There's a gas forming in the test tube, or there's a gas in the test tube. There's water, there's a funnel, and then there's a green water plant. So, the test tube is collecting the gas. So which gas is forming in the test tube? So a couple of ways you can figure this out. This is a question about photosynthesis. So ask yourself, what gas is the product of photosynthesis? And the answer is oxygen. So it has to be oxygen forming in that test tube. So if you couldn't remember that part, you could look up photosynthesis and just think about the reactants and products. And oxygen is the only gas on the product side. So it has to be oxygen forming in the test tube. And then finally, number 5. Which of these statements is best illustrated by this diagram? So you have a tree and some water plants and a fish and a raccoon and a squirrel. And it tells you that the squirrel gives off carbon dioxide and the fish gives off carbon dioxide and takes in oxygen. The raccoon takes in oxygen. But what it also shows you, it doesn't show you that animals underwater eat plants because the fish, it's not eating the plant. It doesn't show that. They might eat plants, but that's not what this diagram shows. Land animals exhale oxygen into water. No, land animals don't exhale oxygen, and they don't exhale anything into the water. Water-dwelling animals breathe carbon dioxide. Nope, because carbon dioxide is leaving the fish, not going into the fish. But it does show you that plants can take in carbon dioxide from the air. So like these plants are taking in the carbon dioxide that's in the air, and these plants are taking in the carbon dioxide that's in the water. So it tells you that plants can take in carbon dioxide from air or water. And then let's switch to the Wednesday, Thursday warm-up questions. Here we go. Ha ha, Merry Christmas. Christmas questions. All right, so Santa lives at the North Pole. What are the longitude and latitude of Santa's village? So you might have known this. You might have been able to visualize it. I couldn't. I had to look it up. And when I looked it up, I learned that the exact coordinates of the North Pole, which is where Santa's village is located, are 90 degrees north and 135 degrees west. So it's answer A. So fun fact, if 90 and 135 north and west are the northern hemisphere, what would the South Pole be? The South Pole would be 90 degrees south and 135 degrees east. So there's the longitude and latitude of Santa's village if you ever want to look it up. NORAD has a great way to do that. Next question. Why is it so cold and snowy at the North Pole? Well, yes, Santa is magic, but that's not why it's cold and snowy. And no, there are not very many trees because it's further north in the tundra zone. But there's still a lot of carbon dioxide in the air because of global warming. Electromagnetic energy escaping from the poles was a sciencey answer provided by Mr. Cook. The answer is cold and snowy because the North Pole receives indirect sunlight. Indirect sunlight equals colder air and water. Number 3, I love this picture. Reindeer. Reindeer have large paddle-shaped hooves with fur on the bottom. Why? Why do they have fur on the bottom? Magic? Maybe. Reindeer might be magical. They have to be magical to visit every boy and girl in the world. Luck? Yep, that might be pretty lucky. It's not a birth defect. They're quite efficient. It is a beneficial adaptation. Adaptations, if you'll remember, are a trait that has evolved over time that helps the organism survive in its environment. So, what purpose do those furry hoof bottoms serve? They decrease friction so the reindeer can slide. While that might be fun and entertaining, especially to watch that happen, furry hoof bottoms would not decrease friction. And reindeer might not always want to be sliding around. To keep the hoof bottoms warm, maybe, but I don't know that hooves are specifically susceptible to cold or feel cold. Is it because hobbits made furry feet popular and reindeer just want to hang out with the popular kids? I don't think so. Reindeer are pretty confident. I think it's that friction needs to be increased so the reindeer don't slide on the ice. So that is actually why they have furry hooves, is to increase friction so that they don't slide around. And then finally, while we're up north, narwhals. Narwhals have over 10,000 nerve endings in their horns. What purpose might this adaptation serve? This adaptation would allow them to sense changes in water temperature. This adaptation would allow them to sense changes in water salinity. This adaptation would allow them to find prey. Or perhaps this adaptation is magical and allows narwhals to do all of the above. And yes, it is. It's magical and allows narwhals to do all of the above because they are magical creatures. All right, so there is your homework, your warm-up question explanation for the week. As always, if you have any questions, see your science teacher. Good luck on your exam, but more importantly, have a very merry, happy, safe holiday season, and we will see you in the new year.